I'm Megatron. I'm a second year at METU Electrical and Electronics Engineering. Now here we have our term project experiment. And the objective here is to understand the relation between a light source to our light dependent resistor and how to measure the distance from various techniques. Um, so in our preliminary work, we are expected to have some understanding of how op amps work and how they can be utilized. And here we have a basic comparator and the understanding of voltage dividers and what a sensor is. And here we will be using lightness and darkness sensors, which we have covered in our preliminary work. So since we are dealing with illumination, it's good to take a note back. After our preliminary work is done, we skip to our experimental procedure. Now here we have our constant DC power supply, which is set for 12 volts. We have constructed the circuit here. It is given in figure 3. And we observe the characteristics of the circuit. The LED should be dimmed out in room conditions. And as the light intensity decreases on the LDR, the LED should be lit like this. So when we are making our measurements, we want the environment to be dark where the ambient light can be taken as 0. So we set our multimeter in voltage measurement mode and we take 5, 10, 15 and 20 centimeters measurement until the LED lights up. So let's try that. So here is the circuit and we will be using a ruler and we have this as our light source. To make the measurements more easier, we have covered the light source as our flash with a double folded A4 paper. So here we can see that about 24 centimeters the LED is dimmed out. So that's our record value. And as we take it from below there, we write down our measurements. This was all part 1. And for part 2, we switched to the lightness sensor. We have covered this in our preliminary work. So there are various ways to achieve this. But here we will be replacing our LDR and our 10K resistor. We can just simply do this by changing the ground and our input like this. So we had our darkness sensor and now we have switched our lightness sensor. So here in our room condition, the LED is dim, as we can see. And as the light intensity increases, the LED is supposed to be lit. So now, again, we will be making our measurements in a dark environment where the ambient light is considered to be 0. So let's go there. Again, by the use of our ruler, we make our, okay. Let's try to see where this happens. And about 24 centimeters again. We light up our LED in our lightness sensor. And we will keep doing this with 20 centimeters, 15, 10, and 5 again. And we write down our values. All right. So for part 3, um, now as we have covered this, illumination, there is inverse square law for relation with distance. Like say we set the light source from our object value with distance x, and we have illumination of I, let's say. So when we put the light source of distance of 2x, then we get I over 4 illumination. So this was an example, of course. So for part A for 3A, we compare and analyze our values that we have measured and got, and see if they fall under our expectancy, like the inverse square law, of course, like when the distance is halved, what happens to the voltage measurement. So for part B, as we did our measurements, for this case, at 24 centimeters, the LED lights up for part 1 and the LED dims out for part 2. So we expect you to comment on that. And for part 4, from those measurement values, we want you to form a graph that should be close to linear, but ultimately an exponential graph between the relation of distance x in centimeters to our voltage measurements, so that we can conclude by the voltage measurements, we can understand where our light source is. So while we are making our measurements, we want the light source to be as perpendicular to the LDR, and thus concludes our objective.